A common task for analysts is to analyze price and quantity data, sales data, to try to make a recommendation for what price you should be selling your product at. So this is one of those areas of overlap where the analyst is acting like an economist, and they want to estimate the demand curve for their product. Now, the simplest demand curve is just going to have price and quantity. So how many units you sell is just going to depend on the price. More complicated demand curves will have the price of competing products, or maybe there's the time of year or the time of day. There might be some cyclicality. It could depend on macroeconomic events. Maybe the whole economy is bringing your business up or down. But we'll start simple. Let's suppose that you have access to this really great data set. Your boss is like a mad scientist, and every day he wakes up wanting to sell widgets, and he picks a different price every single day at random, and then sees how many units of widgets he sold. He does this for an entire year. And then he turns over this data set to you, and he says, all right, what should I price at? Now that seems to be a pretty easy problem. Your boss has already done the hard work, has already estimated or already run an entire year's worth of experiments. Let's suppose that in fact they recorded all of this stuff in this spreadsheet right here. So we've got the day, which runs from 1 to 365, and there were all these different random prices. And, on the first day, the boss tried a price of 31 and happened to sell 107 units. And again, your boss says, so what's the best price? Now, there's a very naive way of doing this and more of an analytic way of doing it. The naive way is just to figure, and by the way, here we don't have any costs. We're just maximizing revenue. So the naive way of doing this is to just estimate revenue and then pick the maximum one. So we would, revenue is just, how many widgets did you sell times the price of each widget. So price times quantity. And you would do that for every single one. Let's just double click. For every one of our widgets. And then we just want to pick the highest one. So we could just sort our data set. And let's go to data and sort. We'll sort by revenues. And let's go largest to smallest because we want the best one. And it looks like here the best price is a price of $49. Now that's a pretty, straightforward means of analysis. There is a problem with this, and it may not be terribly important or it may be very important. The complication is that in anything in life, there's randomness involved. There's a bit of random error. And so this analysis that we just did kind of presupposes that any time that we would charge a price of 49, we would sell 76 units. And we just know that that's not the case. There's always some daily variation. It's just going to be random ups and downs. So what we want then is a way to eliminate or at least minimize the noise in our data set. And regression helps us do that. So let me clear my screen and show you what I mean. Okay, so let's just do a quick reminder here of what a demand curve is. We've got price and we've got quantity. Now this is how economists normally draw it, with price on the vertical axis, on the y-axis, and Q on the x or horizontal axis. And we as economists vary price to see what happens with quantity, which is just honestly a little backwards. For arcane historical reasons, we chose to put P on the vertical axis, but really it acts like the independent variable. When we choose P, we get out Q. So normally, in algebra, you had x in some function, and you get out y. So x is the independent variable, y is the dependent variable. Economists flip that. You can blame an economist named Alfred Marshall. At any rate, we've got our demand curve, which we know is downward sloping, but we've got some data points, and the data points are, they're random, but there's this general downward trend. And I could just take each point and calculate revenues from it. I could do price times quantity and, calculate, for this point, this particular price and this particular quantity. And if we multiply them, we get actually the area of a nice little rectangle there, base times height. And the question is for each one of these points to calculate the revenue and find the best one. But we know that there's a bit of signal through all this mess of noise. If we were to try to fit a straight line, a regression line through these, maybe we would get this red line. And that helps us abstract away from all of these black points. And then we can try all kinds of prices, including the ones that our boss tried out, but also prices that he may not have. I mean, there are, after all, an infinite number of different prices you could have between any two numbers. Between 1 and 100, there's an infinite number of points. And if you're, I guess, dealing with dollars and cents, so you can't subdivide even further, there's still, thousands and thousands of points of price combinations in dollars and cents that we could have come up with that we just don't have data for. And so regression actually serves this second point where we not only just get rid of this random noise, which could be influencing our results, but also helps us interpolate, like let's say right here, between prices and quantities that we had actually observed. Like we observed these guys here, but nothing in between. And maybe the optimum price, the best price is right there. Or maybe it's right here, another place where we didn't observe data. So in summary, regression analysis is going to help us remove the influence of error so that we get more precision. And it's going to help us interpolate between between points to maybe discover a price that's even better than one of the ones we tried out in the previous year. So let's now pull up a data set and see how this would work in practice. So, let's see how this is done. I guess first, any analysis we know starts with a graph. So let's graph our data and see what it looks like. So we're just going to highlight our data, and we can go to Insert, and we're going to insert a chart. And it's going to be a nice little scatter plot, and there we go. We have do we have the right things on the right axes? Let's check here. Oops, let's move this up. Let's cut that and put it at the top. Okay, so our prices vary from, they're, like 2-digit numbers, and the quantities are the bigger numbers. And so this has quantity on the y-axis and price on the x, and we need to switch that. So let's swap the order of our rows and redo this. So I'm just going to copy this column and move it over, and then let's move everything back. And then we'll highlight and insert our graph again. So insert, and then here's a nice little scatter plot. And okay, now we've got a function where the y variable is price. And that's what we want. And one thing we see here is that there is a very well-defined demand curve here. There's a very clear downward sloping relationship between price and quantity sold. So the law of demand holds, and which is good. It should hold because it's the law. All right. So our next task then is to try to extract the signal from the noise, is to try to find that one line best fits through here. Now eventually we'll need an actual equation so that we can play around with different candidate prices. But at least visually, Excel can do this rather easily, just fitting a line through a scatter of points. Let's go back to Insert. Let's select our graph. And then this ribbon pops up, and we're going to add an element to our graph. and we can add a trend line. And we can go linear, but I actually just want to customize this guy a little bit. Let's click on it and make sure that we have linear, which is good. But the default is to put that line in blue, and it gets lost behind all these points. So let's change our color. Let's make it red. Let's make it a little bit bigger, and let's make it a solid line. And that's it. Let's well, there it is. It's in red. I selected solid line, but it's dotted. Weird. Who knows? Maybe it's the dash type or something. There we go. There, now it's solid. All right, so here is what we think is the signal through all of that noise. And I think you can kind of appreciate by looking at this that if we were trying to calculate revenues, which we said was this rectangle, the price times quantity pairs, these guys here, these outliers, they just indicate a very high price for the given quantity, so a lot of revenue. But it's probably because of random error. And so if we were to say, well, it worked before, let's just pick one of these two prices and run with it, we'll be disappointed pretty much every time that we, every day we wake up and we look at revenues. It probably won't match this exceptional performance because that was just exceptional because of random noise. So what we need then is to actually get a true estimate for this red line and then recalculate revenues using the red line, not the blue points anymore, and then see which one is optimal according to the red line. So we're going to use regression analysis to estimate the red line. Let's do that right now. So we know by now that the standard regression or standard statistical tools like regression is in the data analysis tool pack. So let's find this guy. It's under data, and we'll go to data analysis and then find regression. Click OK. And we got to tell it our Y range and our X range. Now it's not going to make too huge of a difference which variable we choose as Y and which one we choose as X. In this case, especially because there's just two variables. But really, we should think about not just how the demand curve was drawn, because remember, the economists kind of did it backwards. The question is, which variable do we get to change? And then what do we see the outcome being? We get to set the price of our product. Then we've got to sit back and see how customers respond and how many units they purchase, what their quantity is. So the stimulus variable, the choice variable, is price. So that's our X variable. The outcome, the Y variable, that's going to be quantity. So again, what's our Y variable? It's quantity. So we can select B1 through, well, we'll go all the way to the bottom. That's B366. And then for our X variable, we want something similar. We're going to highlight C1 through 3, C66. Now that very first row is not a data point. That's a label, quantity and price. We want to make sure we've told Excel, don't try to calculate with a word because you're not going to be able to and it'll mess everything up. So you want to tell it for sure that first row is a label. Some data sets come unlabeled. Those are horrible to deal with. Anyway, we're going to select label, and then we want to figure out where should Excel give us its output, because it's going to print some output. I like to keep everything on the same page, but you don't have to. You can select a new worksheet and just tell it where to go. I don't want a new worksheet. I'm just going to click on here, this output range for the current worksheet, and let's maybe let's put it. Well, we can put it right there. How about there? And it just fills in E1 for us, and then we can just click OK. It does some crunching, and then it spits out what is a standard regression table. Now, there's a bunch of stuff here, and it's kind of overwhelming. So we're going to clean it up a little bit. Let me just make everything a little bit more readable. We'll change the width of the columns. I'll notice, by the way, that there's a lower and an upper confidence interval, and for some unknown reason, Excel gives this to you twice. All right, well, we don't need that redundancy, so we can get rid of those. It turns out that we're not going to need any of this output. We're not going to need any of that other output. In fact, what we want is just the equation of a line. And hopefully you remember from high school that you only need two numbers to determine a line. You just need a point and a slope, or a slope and an intercept, the intercept being just another point. All right, so let's find those two numbers. They are right here, these coefficients. That's really what regression analysis does. The rest are kind of like diagnostics. But the real output of the regression analysis is a line, and that's just a slope and an intercept. All right, so our intercept is this 179 number. Let's highlight that number. That's an important number. And then this thing that's kind of attached to price, that's the slope when you change the price. So let's just highlight those two numbers. Those are the critical numbers, and we can maybe make it a little bit more readable. Everything else, for our purposes right now, we can ignore, which is great. So what is our estimated regression equation? Let's just type it out. I wish I could write with my pen, but we have a y variable. That was the outcome, which was quantity. So quantity, quantity, there we go, is equal to, and then there's, what is it? It's mx plus b, right? What is x? X we said is price. So let me change that and put price. Our intercept, what we call b, we just said is 179.597. And the slope is the number that gets multiplied by price. So the price, you see this is a negative 2.702. It's negative, by the way, because we saw from our scatter plot that there's a negatively sloped relationship between price and quantity. That is the law of demand. Higher the price, the less people are going to buy your product. The lower the price, the more products you're going to sell. All right, so we have now our estimated regression equation. Now we can use this to actually estimate demand for a whole bunch of different prices, including maybe some prices that we have never even considered. So we could set up a little table and try a bunch of candidate prices. So price, we'll get our quantity, and then we'll multiply those and get revenues. All right, so we could try a bunch of prices. We could try 1, 2, 3, and so forth, but I'm going to run out of screen space. So just for the sake of illustration, let's do 5, 10, 15, and 15, and so forth. And we'll go down to, I don't know, let's just do 100 for now. You can try more points. All right, so again, we get to pick the price. So I just picked a whole bunch of prices. How about quantity? Right. Again, we're not going to look here to find the corresponding quantity. We could have tried the same price randomly in 2 different days and gotten 2 slightly different quantities from random error. Instead, I want to use my estimated regression line. We're going to feed in a price, and we'll get out the expected quantity. So we just need to leverage this equation. For example, what quantity would we get if a price were 0? Well, it's going to be this negative 2.702 times a price of 0 plus the 179 number. I'll reference these yellow cells. So what do we have again? We have this negative 2, so that's F18 on my spreadsheet, and I'm going to anchor that down. So it's always referring to that yellow line. Then we're going to multiply it by price. Price here is 0 in this case. And that one I'm not anchoring down because I want to try a whole bunch of different prices. So I want that thing to update. And then we need our 179. And it's always 179. That's our intercept. So I need to anchor that one down. And that is F17. So we use our dollar signs and we get F17. Okay, and what do we get? We get our 179 back because we multiplied this number times 0, so it dropped out and it left us with 179. If we plug in a 5, what do we get? Well, we'll just have Excel make those calculations for us. Okay, so we have this inverse relationship, this negative relationship between price and quantity, again because demand curves are downward sloping. Let's move our graph back up so we can just see it. And keep talking about that downward relationship. There it is. All right, now technically we can't have negative numbers, and so we might want to eliminate those. But I can also tell you that we don't need to really replace them with zeros because if you're getting negative revenues, that's not going to be the optimal price. So you can pretty much not worry about the negatives. You don't need to replace them with zeros. All right, and so finally, for the last thing, we got to pick a price. We have our regression equation, predicted quantities, but what we really want is revenues. So we just multiply price times quantity. So that number times this number, and we hit enter. And of course, price of 0, doesn't matter that we sold 179. Revenues are nothing because you're not getting anything per widget. But if we do all these other numbers, well, we get a whole bunch of different things here. And so now our task is to just find the optimal price. Now, again, this is, I only did $5 increments, so you could do something a little bit more fine. But if we just look at here to try to find the optimal price, well, we just need to find the highest revenue number, and that looks like it's around here. Nope, right there. No, can we do better? No, $29.75 seems to be as good as it gets. So a price of 35. Somewhere around here. Now, what was our price before? I think it was around 40, wasn't it? I shouldn't have deleted that column here. But I'm pretty sure there wasn't 35. So 40 was close, but 35 was actually better. We had eliminated the noise from our analysis and got something slightly better. Now, if you really want to get super precise, rather than doing increments of $5, you could do increments of $1 or even 10 cents or 1 cent. And really, narrow in on the precisely optimal price. At any rate, this is the general way that we would use regression analysis to estimate a demand curve and then use that to figure out what the optimal price is. Some next steps, there's a couple of different next steps. One is to use a multivariate regression rather than just this bivariate, two variable, price and quantity analysis. For example, we may have, maybe we're at a theme park, and we're trying to estimate demand for plush dolls at a theme park. Then the weekend sales are guaranteed to be higher than like Tuesday, Wednesday sales. So we may want to have variables to try to capture whether it's a weekend or a weekday. Regression analysis is completely capable of doing that kind of thing, and then we can either figure out two different prices, optimal price for the weekend price and then the weekday price, or maybe we're constrained to just having one price. We could figure out, given that we're going to gain some on the weekends and lose some on the weekdays, what that optimal single price is. Another way of making our analysis more interesting is to not just focus on revenue, but to take into account that there are costs to producing a certain quantity. So rather than maximizing revenue, we could maximize profits. In other words, taking into account costs as well. That just means that rather than calculating a revenue column, we would also have a costs column. And then we would just do revenues minus costs. Thing is, all of these are next level kinds of analyses. We need, multivariate analysis and profits rather than revenues. So that's next stage thing. We'll save that for a next video. But that's it for now. You now know the basics of how to use regression analysis to estimate a demand curve, and then how to use that to make an optimal business decision. Thanks.